Okay, so for this video, we discuss some questions in geometry. So the first, we check angle. So angle is formed by two layers or two lines. Like say, okay, start from here. So this line to form this angle. Okay, so angle we can use Greek letter alpha, beta. We can use those denote angles. Okay, so then how to measure the angle? So we define this angle that turn around. Let's say turn around one circle, one rotation. This is a 360 degree. We just define this 360 degree. Then okay. So from here to here, so we say this is half. So this is 180 degree, and we also call this 180 degree as a flat angle. Okay, and then half, then this one is right angle. Okay, so right angle, so 90 degree. Okay, so we say this is right angle, and this one it is this flat angle. Okay, okay. So we say like this angle 1 plus angle 2 we all can use angle 1, angle 2 plus angle 2 is 180 degree. So we also call angle 2 is a supplementary angle of angle 1. Okay, so angle 2, angle 1 make a flat angle. Okay, so for let's say, so here we have this result for a triangle. There's three angles. Okay, so ABC, we call it a triangle ABC. So angle A plus angle B plus angle C, angle A plus angle B plus angle C equal 180 degree. Okay. Okay. So why this 180? So we can prove this way. Let's say we extend this line. So let's say we draw a parallel line. Then this angle B, right? This become angle B, and also a parallel line. So this become angle A. This angle A, this angle B, this angle C. So angle A plus angle B plus angle C equal 180 degree. Okay, so now let's say, so we have this result, like let's say here, this angle, let's say if here is this line, and in general we have this angle plus this angle, let's say angle 1 plus angle 2 equal this angle 3. So why we have this result? We say angle 1 plus angle 2 equal angle 3. Why? So because we can say like we just put this as angle 4. So we have this angle 1 plus angle 2 plus angle 4. This is a triangle ABC, a triangle, right? Three angles in triangle. So this equal 180. And also angle 3 plus angle 4 is 180, right? Angle 3 plus angle 4 is 180. So from here we can say angle 3 should equal angle 1 plus angle 2. Okay, so if this is 35 and this is 60, then we have this result. This angle A plus 35 should equal 60. Right? So we can find angle A easily, right? Okay. So this problem part is the same. So here we say for large triangle, so let's say here for large triangle, so this is 90 degree. Okay, so for large triangle, we in general we have thus, we say this angle, angle 1 plus this angle 2, angle 1 plus angle 2 should equal 90. Okay, because three angles together is 180, right? Okay, so if this for large triangle, if these two sides are equal, then these two angles are also equal. Okay, suppose this side 1, this side 1. So these two angles also equal. So these two angles should be a half of 95, 55, 45, 45, right? Okay, so now let's say, so here, this is light, this light and PQ equal PA, then this angle should be 45 degrees. Okay, so we can easily find this angle X. We say, and like 15, this angle, so this angle plus X equal 45. Okay. And so one circle is 360, right? So angle A, so let's say here we have A plus B, this angle A plus angle B plus C, D plus E, F, G. So this is the one circle, so this is 360. Okay? So if A plus B equal, so if this is 200 and CDEF this equal 140, then what is G? So G is just 360 minus 200 minus 140. Okay, and so we can easily find this is 340. So this G equal 20, right? 20 or 20 degree. Okay, so for triangles, so we say here, those are general triangle, like A, B, C. So for general triangles, so we at the first we say angle A plus angle B plus angle C equal 180. And for general triangle, we use this standard notation or labeling. We denote this side as side A, like angle A faces side A. So angle B faces side B. So this angle C faces side C. So ABC. Okay. So for this triangle, so simplest triangle is a large triangle. Okay, so for large triangle, let's say large triangle can be this one, right? So this is large, one angle is a large angle. So we call this side, longest side, as a hypotenuse. Okay, so if this side is A, this side is B, this side is C, then we have this very important result. We say A square plus B square equals C square. Okay, so for large triangle, longest side and hypotenuse, this square equal a square plus b square. Okay. Okay, so based on this is important. So based on this, we also can get the formula for distinct formula between 2 points in rectangle coordinate. Like if this point is x1, y1, this point x2, y2. So what is that distance? What is D? So this is just a large triangle. We just make a large triangle. Okay. So this is just the x, this x minus this x. This is just x2 minus x1, right? And this side, just y2 minus y1. So this side is y2 minus y1. Okay, so there's d, there's square, so we say d square equal a square like x2 minus x1 square plus y2 minus y1 square. Okay, then the distance d so equals this, right? This is just take a square root. So this is, we say this is the formula for a distance formula between 2 points. So if we are giving 2 points, then we can find the distance. Okay, so a square plus b square equals c square. This is really important foundation. This is fundamental important. Okay, so we for these problems are very easy. Like we want to find the hypotenuse of a large triangle. If the legs, so we call this leg. So the 2 sides as legs. So let's say, so legs is here 6, this is 8. Then what is hypotenuse C? So we just use this. There's C, or c square equal a square plus b square. Okay, so we find this equal 100. Okay, so this C equal 10, right? Okay. So triangle is 3 sides. Let's say we have this is triangle. Then 4 sides. 4 sides. So 4 sides. So we just check something formed by 4 sides. Okay. So at the first we have the square and the rectangle. So square is this is 4 sides same. Rectangle is like this, right? Rectangle is this straight line. So this, so rectangle. So if this is A, this is B, then area for rectangle is just A times B. Area is just like A times B. So for square, just A times A square. So here, if this is 8, this is 3, then what is the area for this? This is very easy. Such a problem very easy. Just the 3 times, just the 8 times 3 or 3 times 8, right? No, we say 24. Okay, then let's check the area for the triangle. So triangle, we say the half of, let's say we have the formula. If for triangle, if this base B, so we say we call this the height of a triangle. This B, this H, then the area for triangle is equal half of BH. Why for half? So we can make this is we can say this is just like a half of a rectangle. So for such a problem, so very easy, like half. B is 4, C is 6, So we say the area equal 12. Okay. So then, for some complicated finger or graph, we say usually those things are formed by some triangles. So like a pentagon, or here we have like a hexagon, those things. So we can regard it, oh, this is just formed by this 6 triangles, right? 1, 2, 3, 4, yeah. So we want to find the area of that. So, okay, so we just check this one. Let's say the triangle A, let's say ABO, like ABO. So, this is 6 same, so we can say this angle is 60, because like this we have this 6 angle same, so totally 360 divided by 6 is 60. So for this one, we know AB this equal 4, and OP, or we know this OP equal 2 radical 3. Then this area equal half 4 times 2 radical 3, right? So this one we have 6 of them, so just multiply 6. We have 6 such triangles. So we can say this equal, or cancel this, or cancel this 2. Yeah, and then here 2, 4 times 6, 20, 4 radical 3. Okay, so here we have a circle. So we in this circle we have inscribed we have a triangle. So this triangle is this triangle is isosceles. Isosceles means this. The iso means by the way, so ISO means equal. Okay, so this side equal. Okay, so we know this is 45, and this is a right angle. Okay, 45, 45. Okay, so let's say this circle has a diameter of 10. Diameter is 10. So this AC equal 10. And then we want to find the area for this triangle. So we also can say, we can check this way. Okay, so AD equal 5, right? So AD equal 5. And DB also 5. So we can see, like, we just check this triangle. Here's 5, here's 5. What is the area for this? So area equal half 5 times 5. So here we have 2 of them, so just multiply 2. So the area is just 5 times 5 will equal 25. Okay, and then the area for other things. As a typical, let's say here the parallelograms. So parallelograms just we say this are the parallel, and this here parallel. So this is just like a tangle, but just change a bit. So with area is just this B multiply the H. Yeah, so this time altitude. So we also call this h is height or altitude. Okay. So these things we can see if we just cut this, cut and put it to here, we get the rectangle, right? Okay, and for this one, the area is okay. So if we put this, two of them, so this become like become a paragraph. So, but anyway, like we have this formula is area equal this. We say base 1, or we say just put this as A. This side B, then this H. So the area is just equal half of A plus B multiply H. Okay. And then the area for circle. So we have the formula. Yeah, area for circle. So for the circle, suppose like the circle is reduce R. Okay, what is the area for this? We have a formula equal pi r squared. So pi r squared. Okay, so yeah, use the formula, right? Pi r squared. So r is, we call this as a radius. Okay, so this is the formula. Like for this, so like for this circle, if this r equals 3, then the area is just pi times 3 square, right? A equal pi times 3 square, or equal 9 pi. Okay. So we also can find the like area, or there's a limit of a, like we also can find the side of, or let's say we have regular pentagon. The pentagon, what is the regular pentagon is pentagon is 5. Let's say like this one. Oh, this become a hike. Yeah. Or this is pentagon is this. Oh, I do not use that. Maybe this one. Okay, like this pentagon. Okay, 5 side. Okay, so regularly if we send it here, so we just the pentagon is formed by 5 of those identical triangles. 5 triangles. So we want to find. Oh, this is easy. This the sides measure 4. Like this is 4, or then this is 4. This is 4. The 4 times 5. Yeah, pentagon just. So pyramid. This is very easy, right? Okay. Okay, so then we have 3D. 3D. So for 3D, so for 2D, we have area. For 3D, we have volume. So we just check some simple the case. Like so square. So here we have a regular solid. So just a rectangle becomes solid. So let's say rectangle, the 2D, right? So this side is A, this side is B, so this is rectangle. Okay, so so 3D, just like that. Let's say AB, just like that, right? This becomes 3D. Okay. Okay, so this side A, this side B, then we need this other side. Suppose this side like this. So which one is B? So A, B, no, sorry, B. Then this is C. So we say volume is just A times B times C. or we also can say this equal, in general, you just equal base area for base, volume equal area for base area of base multiply the height. Okay, so the area rather the volume is, we can say the 4 times A, so this is the base area, right? So multiply, so we can regard this is height. So height equals 3. Okay. Okay. So this is so find the volume for, we only can find some typical case like this one. So we call this as a cylinder. Okay, volume cylinder. So this is just also same, volume equal base area for base multiply the height. Okay, so see here base is a circle. So circle area equal, so pi r square. So height is h. So pi r square h. So if we know, if we are giving this r or h, then we can find the volume. Okay, so those are material for geometry. Okay, so we basically we have the two, or we have the 3 things. First one is angle. Then we have area for 2 dimension, right? For angle or 2 dimension, for we have area. Then for 3D we have volume. Okay. Okay. So we can stop here.